So, we are using sodium carbonate and we are going to be using hydrochloric acid. And we've already done 4 tests, and our first test was 15 grams of sodium carbonate and then 25 milliliters of hydrochloric acid. And we did this in a quart bag because we thought that if we could find a good ratio, then we could just multiply it by 4 and then it would fill up the same as a gallon bag. And so we did 3 other gallon bag tests. We realized that using 50 grams of sodium carbonate was way too much and 100 milliliters of hydrochloric acid was too little for the 50 grams. And then we did test 3 where 25 grams of sodium carbonate and 75 hydrochloric acid was a perfect pressure, but still it was a little too overinflated. And then our test 4 gallon, it was 22 grams of sodium carbonate, 75 milliliters of hydrochloric acid. It inflated the best out of all 3 of them, but we still knew that the limiting reactant was sodium carbonate. And so today we're going to be measuring, we're going to be using a quart bag with 9 grams of sodium carbonate, and then we're going to be doing 25 milliliters of hydrochloric acid. We're going to start right away, but okay, so why are we doing it? Okay, so we are going to be doing 9 grams and 25 milliliters of 9 grams of sodium carbonate and 25 milliliters of hydrochloric acid because last time on the first test we did 15 grams of sodium carbonate and we thought that was a little too much, so in test 5 we realized that a quart is a little too small for 9 grams of sodium carbonate and it overinflated by a lot. A huge margin actually, so we decided to use the same numbers, but we're going to switch it to a gallon bag. And instead of using 25 milliliters of hydrochloric acid, we're going to be using 40. And the limiting reactant is hydrochloric acid, so we're going to keep a variable, which is sodium carbonate. We're going to keep that the same, and we're going to switch hydrochloric acid. It's 40 milliliters of hydrochloric acid and 9 grams of sodium carbonate.
3, 2, 1.
Why do you still have your phone?
Yep.
Okay, so our last trial did not work. It exploded. The egg literally hit it and it exploded right there. And so we realized that the middle had a lot of pressure and air, so you could put your finger in it and it wouldn't touch the ground. But as soon as you put your finger on the sides, the egg just hit the side and it broke right there.
Yeah, but in addition to that, as it hit the bag in the middle, it grew tons. So it was basically just like hitting a table.
Yeah, and so for the next trial, we'll probably mess with fix our calculations, and then we'll probably end up doing a little more of our product. So we're using sodium carbonate. We'll probably add a little more of this and a lot more of this. So that's what we'll be doing.
Yeah. And then another idea we had was to actually try and get rid of some of the air as it's inflating. So we could use the trials from before that produced too much gas and then add in a very small hole, so that way as the egg hits, the air that's displaced by its force is able to escape.
So it goes
and it actually
drops it into
deflates.
a nest.
Yeah.
So yeah.
Alright, so today we're going to be trying out another reaction, but this time using 9 grams of sodium carbonate, but increasing the hydrochloric acid up to 50 milliliters. Last reaction, we got the inflation we wanted, but it still ended up being too little, and the egg just ended up shattering. So this time we're incrementally increasing the hydrochloric acid in the hopes that we can get it to the right inflation where it won't bounce as much and it'll still protect the egg. So for this test, we're going to be using 12 grams of sodium carbonate and 50 milliliters of hydrochloric acid. We did do a previous test with 9 grams of sodium carbonate and 50 liters of hydrochloric acid just to see how the more acid would affect the reaction. So this time we're going to be improving on that and also increasing the amount of sodium carbonate.
12 grams of sodium carbonate and 50 milliliters of hydrochloric acid.
Alright.
Go when you're ready.
3, 2, 1.
Oh, it survived. Okay. It's the same reaction. You can go. Okay, so we did 2 test runs and they were exactly the same. So we did 12 grams of sodium carbonate and we did 50 milliliters of hydrochloric acid. And we did our first attempt, which will be shown. We kind of missed the bag a little bit and it like just hit the ground and it broke. And then the second test run, and so like the bag broke, so it popped a little bit, so we had to redo another test. So we filled it up, and then this time it filled up a little too much, and we dropped it, and it like literally bounced off like 5 feet above the ground, and it broke. So it didn't really work, but we have some changes.
For those test runs, we got an assignment in which we were to calculate how much reactant we needed to create the amount of carbon dioxide we wanted. So through that we found the values of 14.2 grams of sodium carbonate and 46.11 milliliters of hydrochloric acid. So we're going to try using that in the next run, as well as possibly testing out new bag ideas. We aren't sure about that though.
So sodium carbonate and hydrochloric acid, we ran out of it in all the classes combined. We've all used all of it. And so for a supplement for hydrochloric acid, we're going to be using muriatic acid, and we're going to be using what was it? Arm & Hammer with OxiClean, and the Arm & Hammer OxiClean has 70 to 80% sodium carbonate. So those are supplements.
We also have to pick up gallon bags because they ran out of those.
Yeah. So we ran out of our other ingredients. We were going to use this, but this did not react. And instead we are going to be switching to calcium carbonate and hydrochloric acid. And we will probably be doing 9 pieces of Tums and 75 milliliters of hydrochloric acid. And we will be putting little holes in the bag, so when the egg drops, it hits the bag and it like doesn't bounce off. And then also, it will create like a pocket for it. And yep.
Did you guys try it?
Which will hopefully prolong the time of impact.
Okay, we can't like the liquid. Okay. Recording.
This guy? That's gonna bounce.
Not yet, just wait. Okay.
Alright, ready?
Yeah, go when you're ready.
3, 2, 1.
It opened. We totally busted the bag, and it went straight through. I think the egg fell on the side, but if I remember, it fell on the I think it fell like this, and then it shifted over and fell on the side and hit the ground because it went through the bag. And we thought it would work.
Yeah.
We thought everything would go well, but it did not go well at all. So, and if we could do it again, we would probably test a lot more.
Yeah.
And
But,
yeah, we test a lot more.
yeah. Regarding the last test, though, if we were to redo that, I'd say probably have it inflate a lot more and then have slightly larger holes, just so that when the egg does hit, more air can escape and it isn't as tense.
Yeah.
That way the egg won't break through as much.
Mm-hmm.
Hopefully.
Cut it like kind of in half, and then you put calcium carbonate in it, which was, we used Tums. Then you use hydrochloric acid.
We were tasked with protecting an egg from a one-story fall using nothing but a gallon-sized Ziploc bag and a gas-producing chemical reaction.
And the materials we used were sodium carbonate and hydrochloric acid. Oh.
On the final day, we had to change equations. So in this new equation, it was 1 mole of calcium carbonate plus 2 moles of hydrochloric acid, which produced 1 mole of calcium carbonate 1 mole of carbon dioxide, and 1 mole of water.